Hey there, everybody. I am going to try to do a quick Euler's method how-to con video. Um, they take several different styles, and this is one of them. Uh, we are trying to make a prediction as to where this function will be at f of 6.5. And if you look at this, they're just changing things up a bit to keep you sharp. This is a step size of 1.5. Oftentimes, you get greater accuracy if the step size is quite small, but perhaps this is relatively small in regards to what type of problem it is, but oftentimes it's less than one. Anyway, I'm going to just make a little chart here to kind of organize things. It's difficult to do it just with the mouse pad. Not going to be as good as Khan when he does it. And hopefully this will make some sense. Okay, so what I'm going to do, I'm just going to have more rather than fewer things because sometimes this does help. That's our number of steps. Here's our x, here's our y, here's our dy dx. I'm just going to use y prime a lot of times because I'm just faster writing that way. And then this is the multiplier, in this case, by the step size. So this is the delta x. And then this is the resultant delta y. You'll see how this works, I think. Okay, so when we're starting, they're telling us up here that when I plug in 2 for x, I get -1. So there's my 2, there's my -1. And then what is the differential here? Well, a lot of times you're doing the math. You've got a differential equation that's got dy dx is blah, 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 like a slope field type thing. Here, they're just making it easy on us. And they're telling us that at 2, the derivative is 3. So I'm going to put in 3 right here. However, with a slope of 3, if the step size were 1, that would be, I put a 1 in there for delta x. But here, this is what the change would be in y. In this case, the step size is 1.5. So that's my multiplier. Okay, I'm going to multiply the change in x times the slope, and I'm going to get 4.5. So my y value, because of the slope, is going to increase by 4.5. Well, if I'm going to my next step then, it's going to be step 1. My first step will be then at 3.5 because that's how big my steps are. They're 1.5 units, and 1.5 plus 2 is 3.5. Okay, well then, what's my change in y? Well, that's the delta y right here. I'm going to add that on. So -1 plus 4.5 is also 3.5. Don't be misled by that coincidence. Okay, and now I just repeat the process. I look up what is the slope. The slope or the derivative right here is 2. And so I'm going to put that in right there. I'm going to multiply that by 1.5. And I get 3. So that's my change in y. Again, this is going up to the second step. I'm at 5. It's going to be going up from 3.5 by 3 to 6.5. Sorry, I cannot write faster. And then my dy dx, I look up here, and at 5, it's a change of 1. And again, I'm multiplying by 1.5. And I get then 1.5. So again, that's my change in y. My change in x is also 1.5. So my third step here is going to be the all-important one at 6.5. And you can do the math here while I'm slowly scratching away at this. The change in y from adding 1.5 is going to go to 8. And I believe that is what we are trying to figure out right there. So I can go and type in 8 and then click that guy. And there we go. All right, let's try another question. This one is a little more typical, right? We're given a starting point. We're trying to go 2 steps with equal size to approximate 3. Well, if I'm going from 1 to 3, guess what? I'm going to go 1 to 2, then 2 to 3. Okay, so again, I'll try quickly with the chart, and there we go. And here's my n, here's my x. You could do this faster. By the time I did this, this is the delta x, and that's my delta y. All right, so when I start at 0, my starting point, my 0th step, x is 1 and y is 2. My delta x is how big my step is. Well, if I'm taking, like I said, 2 steps to get from 1 to 3, my step size is 1. And then my delta y is going to come from my slope here. Oops, I needed to put that in. It's all right. We'll just do it without. I just can't draw that quickly. What is x plus y is 3. So my slope there will be 3. And since the step size is 1, this is going to be very conveniently exactly what my derivative is here. Because I'll clean this up a bit. That's my times my step size of 1. Okay, so that's the first step. Then, or that's my 0 step. Then my next step is going to be when I'm at 2. Okay, and my y is going to come from my delta y. I've gone from a point of 1, 2. I'm going up by 3, so I'm going to be at 5. I'm adding this to my x, and I'm adding this to my y. Then I do the same thing again. 2 plus, our x plus y is 2 plus 5, that's 7. And then sorry, that 7 goes over here. I can't erase. This is just a 1. And again, I'm just going to add to get to the second step. I'm going to add the 1 from right here and the 7 to the 5 right there and get 12. Okay, so f of 3 should be 12. And with this, you'll be put out of your misery. What do you know? Got it right. Oh, next question. Should we do one more? I think I'll just get you started on this. Similar thing, different differential equation. We're starting at 0. Okay, this is a little bit different. Let's do this. We're starting at the point 0, k. And they are, yeah, okay, we'll do the whole thing. So there's n, there's x, there's y, and then this is the derivative. I'm just going to call that y prime to save time. And then when I'm starting at 0, my y value is k. Okay, what's my expression here? Well, when I plug in 0 for x, and then I subtract 2 times y, which is k, I just get negative 2k. Okay, and the step size is 1. So my delta x here is always just going to be going up by 1. And then my delta y is going to be that 1 times this. So that is also going to be the same thing there. That is always going to be 1. And then this now is minus 2k. So I'm at k, and my change then is I'm going from 0, I'm adding the delta x, and then my k, I'm adding the delta y, and I'm at negative k now. Okay, so now we just repeat, and when I go back up here, 3 times 1 is 3, minus 2 times minus k is going to be 3 plus, hard to make the plus sign, 3 plus, and then 2k. And now, just in the interest of saving time, this is going to be 1. When I multiply 1 by that, I'm just going to get that. So we know that this is going to go to 2. And that's what we want to approximate. And when I add this to that, I am going to get 3 then plus k. And we know that 3 plus k right out here is 4.5. So if 3 plus k is 4.5, I subtract 3 from both sides, and k is 1.5. There we go. Okay, thanks a lot, folks.